Standard industrial land in London typically trades between 4.5 and 6 million pounds per acre, yet adjacent identical plots are commanding 8 to 15 million pounds. This valuation gap appears globally. In the United States, specific industrial plots are trading at 3 times the value. The price premium is paid for what sits beneath the surface. This plot features a legacy high-capacity connection to the high-voltage electrical grid. In the digital economy, this asset class has a specific name: powered land. The physical limit of the AI boom has moved past silicon chips and fiber optics. The current bottleneck is finding a physical site with enough electrical capacity to actually plug those massive systems into. The digital age has rewritten the classic real estate priority. Location is secondary to power, making direct grid access the most valuable asset in the European tech landscape. To understand why a grid connection is dictating global property markets, we have to look at the physical energy draw of a modern AI cluster. Traditional enterprise IT workloads fluctuate. They can be staggered or scheduled to run during off-peak hours when the local grid has excess capacity. AI applications operate in megawatt clusters. These arrive as continuous, high-density loads that frequently exceed 100 megawatts for an individual application. These workloads require firm, sustained power at a scale that the existing grid was never designed to provide. These enormous power requirements turn AI facilities into grid-defining assets that dictate the layout of the local physical infrastructure. This demand is currently overwhelming the traditional European data center hubs, known collectively as the FLAP-D markets. That group includes London, markets like Frankfurt, cities like Amsterdam, and central Paris. The pressure is highest in Dublin, where the local infrastructure is facing unprecedented stress. Data centers now consume roughly 80% of Dublin's local electricity. In cities like Amsterdam and London, they account for between 1/3 and 40% of the total energy demand. Because the grids are maxed out, developers are hitting a structural wall. Connection queues across Western Europe now span between 7 and 10 years. In Britain, the wait stretches to 15 years. The National Energy System Operator currently has 140 data center projects, representing 50 gigawatts of demand, waiting for a connection. A 15-year delay is a terminal hurdle in the AI race. It is forcing hyperscalers to find extreme, unconventional alternatives to secure power. If the standard grid cannot provide power for a decade, developers have to find sites that already have it. Logistics operators are now reappraising their existing land banks, checking if their warehouse sites have hidden, underutilized electrical capacity. Investors are also moving into disused heavy manufacturing sites and chemical plants. These decaying industrial facilities are being repurposed for their legacy electrical connections, which provide the massive power flows required for AI. Others are partnering with large-scale battery storage projects to stabilize their own supply off-grid. Acquiring powered land is now a primary, aggressive investment strategy for the world's largest tech companies. In the modern era, geographic location is no longer the defining priority. Access to energy is. Powered land is the digital gold standard. The foundational infrastructure of the future will belong to those with secured physical access to the high-voltage grid.